Alright, so this is Unit 7, Day 8. This is solving equations using radicals. We're showing you this because when you get to completing the square and a few more lessons, it's going to be important. But you need to recognize one really important thing. If you look at all the problems on this page, you have no x term. The only thing you've got on there is either an x squared or parentheses squared. So this method does not work if you have something like x squared plus 2x equals 25. Okay, this method does not work if you have that extra x term there. So be very vigilant in looking at your problems before you decide to use this method. All right, so the process says get the term with the exponent by itself first. Then you can square root each side. And hugely important is that anytime you take a square root, you're going to get two answers, one positive and one negative. Now, the lesson before this, you were simplifying square roots, and we didn't talk about positive or negative answers at all. And here's the rule of thumb. If you have to put a square root into an equation to solve it that wasn't there to begin with, you deal with positive and negative answers. If the square root was already in the problem, you just worry about the positive answer. Okay, so on all of these problems, we are going to add a square root to solve, which means we have to deal with positive and negative answers. We'll always get two. The other thing to keep in mind, too, is that when you're solving equations, the highest exponent in the equation tells you how many answers you're going to get. So since all of these have a square in the problems, we're going to expect two answers for every single problem that we do. All right, so let's start. Example number 1 says x squared equals 16. Step 1 said to isolate the term that has the square on it. Well, that would be the x, and it's already by itself. There is nothing else on the same side of the equal sign as that x squared. That means we are ready to take the square root of both sides. So I'm going to take the square root of the left side. Okay, that is the opposite operation from squaring. And whatever you do to one side of the equation, you must do to the other, so I'm going to square root the 16 as well. Well, the square and the square root, being opposite operations, cancel each other out, and we get x equals. Now, what number times itself equals 16? Well, most of you are going to say 4 does. But I also remind you that I told you were going to get two answers. 4 times 4 does make 16. But what's negative 4 times negative 4? That also makes a positive 16, and that's why you get two answers. So you get a 4, and you also get a negative 4. Now you can list your answers that way, separately, or New York State allows you to do this symbol, which you are about to see in another lesson or two, positive or negative 4. Those two say the same thing with just less writing. But you do need to know this notation. You will see it again in the very near future. So our two answers are 4 and negative 4. Okay, example 2. At any point along the way, if you want to try a problem by yourself and see if you do it right, you can always pause the video, do it, and then come back and play the video to see if you did it the right way. So number 2, first step said isolate the term with the x squared. Well, it's already by itself, so our next step is to square root both sides. The square cancels the square root, so I have an x. And then the square root of 49 is 7, but I am not going to forget that every time I put a square root in the problem that wasn't there, I get a positive and a negative answer. So you could write it with the plus minus in front, or you can list them separately as a positive 7, negative 7. Doesn't matter. All right, so number 3, a little bit different. The instruction said for the first step to isolate the squared term. That means get it by itself. And right now, it's not by itself. There is a 2 touching that x squared. So before I proceed, I need to get rid of that 2. I'm going to get rid of the 2 by dividing both sides by 2. That'll give me x squared equals 25. Now my x squared term is isolated, so I can square root both sides. A square cancels the square root, leaves me with an x. Square root of 25 says what number times itself makes 25? Well, that would be a 5. And don't forget the positive or negative. That's the biggest piece of today's lesson, is you will get 2 answers when you take a square root. If you would like to write it this way, you can. And for those of you whose number sense might be a little rusty, you do have a square root button on your calculator in case you haven't found it. It's the second x squared keys. So you have to hit the yellow second button and hit x squared to get your square root function. All right, number 4. An x squared term is not isolated at all. It's got a couple different things that's bothering it, so we need to get rid of them. Remember, whoever's touching your x squared is probably the last thing you're going to deal with. So first thing we're going to do is move the 4 to the other side by subtracting. That gives us 5x squared is equal to 40. X squared is still not isolated, so we're going to divide both sides by 5. So we get x squared is equal to 8. Now that the x squared term is isolated, we can square root both sides. So the square and the square root cancel, and I'm left with x. Now, I've got a bit of a problem because square root says what number times itself makes 8, and I can't think of one. So this is where a lot of times the regents will say, give the exact answers. Exact answer means you're not going to change an irrational square root into a decimal because the irrationals never end, and that would be rounding. So if they say exact answer, you're going to leave the square root in it. If they want you to convert it to a decimal, they will tell you what decimal place to round to. So we're going to practice the exact answers. So I know I'm going to get a positive and negative answer. So the first thing I'm going to do is write down my plus minus before I forget. Then what I'm going to have to do is take that square root of 8 and do that prime factorization hockey stick thing we were doing in the last lesson to simplify it. 2 goes into 8, so let's see, 2 times 4. The 4 breaks down into 2 times 2. Here's my hockey stick. Because I'm dealing with square roots, I want groups of 2. For every group of 2, 1 comes outside. So I get a 2 on the outside. I still have this little 2 on the inside. Don't forget, you get a positive and a negative answer. Put our x equals back on. So our 2 answers, if you wanted to separate them, would be positive 2 root 2, and the other one would be negative 2 root 2. Those are the exact answers to this question. They're going to be simplified radicals. Number 5. Okay, number 5 is a little bit different. Sometimes when people see number 5, their first instinct is to write this down twice and multiply it out, which you can do, but you're creating yourself an awful lot of work, okay, and a lot of places to make mistakes. It is possible to solve it from here, especially with some stuff that you're going to learn in the next lesson or two, but there is a shorter way and a more efficient way, and that's what we want to look at. So when you group things in parentheses, you're kind of putting things in a box. So when I see parentheses, I see a single box with stuff in it. That single box is being squared, which means the item with the square on it is in fact isolated. It's a box with a square, nothing touching the box on the outside. Therefore, I am ready to go ahead and square root both sides. So I'm going to square root this side, and I'm going to square root that side. And again, the square and the square root are going to cancel each other out, which leaves me the box, the x plus 1 in parentheses. And on this side, I'm putting down my plus minus right now before I forget. And I get square root of 24, which I know does not come out even. I can't think of a number times itself that makes 24. So once again, we have to do some simplifying. 24 is, let's see, 2 times 12, then we get 2 times 6, then we get 2 times 3, make the hockey stick. I'm taking a square root, I want groups of 2, So here's one group of 2, and that's the only one I can make. For every group of 2, 1 comes out, and it goes right in front of the radical, in between the plus minus and the radical sign. All right, so I've got a plus or minus, a 2, and a radical, and that 2 and the 3 that we didn't group together before, okay, whoops. These guys, jeez, having a hard time, sorry. These guys right here get multiplied back together, and they stay under the radical to make a 6. Now, I'm not done, because I have this box over here, this x plus 1 box. Since there's nothing touching my parenthesis anymore, I don't really need the parentheses. I can open my box. So I'm going to call this x plus 1. I don't have anything to distribute. I can drop the parentheses. When we solve equations, our job is to get x alone, and my x is not alone yet. So I need to now subtract 1 from both sides. So now I have x equals. And the tricky part is looking at the other side. I have this negative 1, and I have this yucky looking radical over here. I cannot add those together because they're not like terms. Okay, one regular number and one radical number, very different species. So kind of math etiquette is to put the nice looking numbers first and the ugly looking numbers behind. So we're going to write the negative 1 first, and then plus or minus 2 square root of 6, and that's as far as we're going to be able to go. This is the exact answer. Now remember, we do still have 2 answers. One of the answers is negative 1 plus 2 root 6. The other answer is negative 1 minus 2 root 6. But nobody in New York State requires you to list them separately. You are allowed to leave it with the plus minus and count that as your 2 answers. They're just put together instead of separate. Okay, you can write it either way. We don't care. All right, so number 6 is just like number 5. This would be a good time to pause the video and try it on your own and see how you do. Here I go. Since the parentheses is the only item that has the square on it, that means the term with the square is isolated, and I am going to square root both sides. The square cancels the square root and leaves me with the x minus 3. Now that was in parentheses, but since there's nothing touching the parentheses, I know I can go ahead and drop them. So I will do that and just call it x minus 3. I know I get a positive and a negative, so I'm going to write that down before I forget. And then a little helpful hint is if you don't know your squares very well, you could type it in the calculator first. But if you type in square root of 121, your calculator is going to tell you the answer is 11. So I don't need to worry about simplifying it. I can type it in and test it, and if it's a perfect square, just write down the answer. So now I have x minus 3 equals a positive or a negative 11. My x is not yet alone, so I'm going to add 3 to both sides. Now last time we said put the pretty number in front. Well, they're both pretty numbers, so I'm still going to put the 3 in front, plus or minus 11. This time I cannot leave my answer that way because I don't have radicals. I can actually add and subtract these numbers, so this is where I want to separate my 2 answers. One of my answers is 3 plus 11. My other answer is 3 minus 11, and now I'm just going to do those. So one of my answers is 14 when I add, and when I subtract, my other answer is negative 8. So those are the 2 possible values for my x. If they don't have radicals, you can go ahead and add and subtract. If they do have radicals, don't separate. All right, number 7. Again, good time to practice. Pause the video, come back and look. The square term is not isolated, so we're going to add 3 to both sides. So you get x squared equal to 48. And now that the square term is isolated, we're going to square root both sides. So the square and the square root cancel. That leaves me with 8x equals positive or negative. If I type square root of 48 in my calculator, I get a yucky decimal. So that means we have to simplify. All right, I don't know if I can squeeze it in here, but I'll try. 48 is 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. So I didn't quite make it. Here's my hockey stick. Okay, I'm doing square roots, so groups of 2. For every 2, 1 comes out. So I get a 2 from the first group, a 2 from the second group. Whoever comes out multiplies. So final answer is x equals, the positive negative comes first. Whatever comes out gets multiplied, so I got a 4. And then the only thing under the radical is a 3. So whoever comes out of the radical goes right in front of the radical, in between the plus minus and the radical, every time. So positive, negative, 4 root 3. All right, last example. Again, good one for you to try first. We have to divide everybody by 6 to isolate the squared term. 432 divided by 6 is going to be 72. Square root both sides. X equals, write down your plus minus before you forget. And we need to simplify the 72. There's no way I have room over there, so I'm going to write it over here. Square root of 72 comes out yucky if you type it in your calculator. So 2 times 36, 2 times 18, 2 times 9. 2 doesn't go into 9, but 3 does, so 3 times 3. Hockey stick. Groups of 2. There's a group of 2s. Here's a group of 3s. So I'm going to have a 2 come out. I'm going to have a 3 come out. They get multiplied. So x equals, my positive negative comes first. 2 times 3 makes 6. Square root, the only dude in my hockey stick I didn't cross off was that 2. So my two answers are positive and negative 6 root 2. So, moral of the story, if you use a radical to solve an equation, you must use the positive and the negative answers. Okay, Unit 7, Day 8 homework is what goes along with this lesson. Please complete it.